Endeavor Houston, Ohio gozaimasu, Aogumi and Mori-san from Akiko.
Good morning, Mario. Thank you for the my favorite. When I was young, I saw this anime SS film. Thank you. I enjoyed.
Basic idea here is we're mapping this globe, and we talk about making a complete map, but you can't actually do it in sequence the way you would think, because we orbit the Earth and the Earth turns underneath us. So the Earth is slowly turning this way as we're going around in space. And so you see, I don't know if you can see it on the downlink, we put some tracks on here. Yeah, there you can see the track. So on one orbit, we'll be coming up this track here, and as the Earth turns under it, on the next orbit, we'll be coming up this track. And you can see that the tracks are spaced apart. So in order to map the entire Earth, we have to go around such that we come back around a later time and we'll be on the track next to this one. And that's why it takes a long time to get the entire map, because it comes in pieces, and when we miss a piece, you can't easily come back and pick it up because you have to wait until this orbit path repeats. We also have on here, if you can see it, there's a line here that shows you how far north we're going. This is the line that is the upper northernmost limit of the section of the Earth that we're mapping. And down here is the southernmost limit. I'm trying to get in the light so you can see it. There you can sort of see it. There's the ring. You can see on the southern end, you get all of Australia. And we go down to the very southern tip of South America. On the northern end, we cut through the northern parts of Russia, and we get just through the southern tip of Alaska and the northern part of Canada. I don't know how much of that you can see, but that's a brief description of how we're doing this map for STS-99.
And Houston, we're flying right over the border between Libya and Egypt right now, and that's what Momo's taking pictures of. Coming up south the track, we'll be able to see the Nile River and the Delta, then we'll cross over into Turkey.
Roger.
Okay, Steve, we're going to let Dom and Memora do the tape change here. What you see on the computer that Memora was just pointing at is our recorder interface computer. It's the one that tells the PHRs, our recorders, what they should be doing. And right below it, where Dom's hands are, is PHR2, our number 2 recorder, and his right hand is on PHR1, which is our number 1 recorder. Those are the 2 recorders right now that are recording sea data. And we're in the process of handing over from PHR2 to PHR1, or correction, hang on. We just went from 1 to 2, and you see the message, I don't know if you can read it, came up on the screen. It says PHR1, change tape. So we're going to take the tape out of PHR1 because it's now full. PHR2 is the one that's now recording. So Dom has got his hands on the door for the recorder. You open the door and the tape pops out. See, Dom's got the tape in his hands. Take the sticker off that records what kind of tape. It's a C-band tape, and the number on the side tells us the sequence. We give him a clean tape. Dom just checked the tension on the tape to make sure it's ready to go into PHR. He's writing down the time at which the tape goes in. And he crosses out the PHR number, so post-flight we can keep track of what recorder the machine is in case we need to play it back in the same recorder to get the best data. You check the tension again, puts the new tape back into the recorder. Locks the door down, and then we'll initialize the recorder after he puts the label on for the new tape number. We put the labels down the side of the recorder so we can scan around the cockpit when the tapes are inside and know which tapes are in which machines. We go back to the recorder interface computer and tell the computer to send a command to the recorder to initialize the tape, which puts a little bit of a leader on it so we know the tape is all set to go and queued up to the right place. You probably can't see what the computer's doing, but it's taking the tape from standby mode to stop, and then it's going to format it and write a leader with a built-in test on it. That takes about 3 minutes for that whole process to run. And you see just at Don's left shoulder, there's a tape bag here. We've got 9 tapes in there, and that tape was the last tape to fill the bag. So Don's going to take the bag off the floor, but keep it and take it downstairs and stow all those used tapes in our downstairs stowage and bring up a whole new bag of fresh tapes for us so we can be ready to change another tape.
Why do we need more maps? I thought we had plenty already.
This map is going to be more accurate than any of the maps that we currently have in 2 ways. The global maps that we have are gotten by piecing together maps from several different sources, and this map will be made all in one pass with the same sensor, which won't give you artificial cliffs. And secondly, as technology improves in any other field, the maps get better and better. And this map will be more accurate than any other previous map. We only have about 2 to 5% of the Earth mapped at this resolution that will now have the whole Earth, or at least approximately 80% of the Earth mapped at.
Using something called radar imaging. Janice, can you tell me exactly what it is that you have on board Endeavour that allows you to accomplish this?
That's why we have this model here, Matt. You can see this is a model of the system we have on board. What we have in the bay here, this large piece is an antenna, and there's another skinny piece on the side that's a second wavelength. We have this 200-foot mast, and on the end is a similar antenna with 2 different kinds of wavelengths on it. And this is a transmitting-receiving antenna. This is a receiving antenna, so it gives you sort of a stereoscopic effect of the radar radiating out from this antenna being received by both antennas, which allows us to get the height data.
What do you think is the first most important thing we should tell our children about space exploration? That's for Memorial.
Yes, every children have a dream. Some people want to become doctors, some people want to become carpenters. But at the same time, many people are enthusiastic exploration of space. So those who have that kind of dreams just continue having dreams, and then they will realize that the only thing, not only children, but also adults, and all over the world people, I think 21st century will exploring space farther and farther and will benefit all of the humankind.
Could you just explain to us, using that model in front of you there, the nature of this problem with that bulky thruster?
Sure. We have a very tiny thruster that's on the end of this long 200-foot mast. It puts on a very small amount of force, just about the weight of a penny if you had the thruster on your hand. And it's just to help keep this thing lined up properly on the track. That's such a small force that our shuttle jets can compensate, but it takes a little extra fuel. They think maybe there's some ice blocking the ports. They're trying to work on that problem to clear the thruster problem. And as you mentioned, in the meantime, they are trying to adjust the way we use our propellant on board so that we will use less of it to make up for that small extra they're using to compensate for the thruster that's blocked.
If I can make it there, I'll make it anywhere. It's up to you, New York, New York.
Good morning to the Redshift, and especially any of the New York natives that are on board.
Good morning, Chris. It's always great to wake up in the morning to hear Frankie's voice. And during our quarantine, we had a training film called My Cousin Vinny. So now everybody on this crew is at least honorary New Yorkers.